All right. So last week was in depth, right? That was all the camera angle stuff and the positives and negatives, and hopefully we didn't kill your enthusiasm for 12 lead because, like I said back then, it's a little dry and it's not the most exciting stuff, but it is important for moving forward. Certainly something for today that if you're not fresh on that you want to go review toward the end of that last video was, if we remember, when we move upwards in those little boxes, in the big boxes, we're talking about height in millimeters, and when we move from left to right, we're talking about time, right? So those are going to be important concepts for today. But the first thing I want to talk about, well, two things we're going to talk about today are, why is it called the QRS complex? Because as of right now, we've just been drawing a triangle, right? And the P wave goes upright and the T wave goes upright, but it doesn't have three letters associated to it. So why does the QRS complex have three letters associated to it when the other two are just called the P and the T wave? So we're going to sort that out. And then we're going to talk about our first electrical problem in the heart. We're going to talk about a right bundle branch block. So when one of your bundle branches, so in this case the one that tells the right ventricle to beat, when it doesn't work anymore and electricity doesn't go down through it. And what does that look like? So let's get started. Scroll down here, go past our heart. So okay, why is it called the QRS complex, right? So this is what we've been drawing the whole time. P wave, QRS, T. So then there's our normal heartbeat that we've been looking at, and it should look very similar to everything up here, right? There's P, QRS, T. So QRS complex. So in the last video I said that the QRS, depending on which lead you're looking in, can actually look different, right? And the reason it's called the QRS is because whether we see it or not, sometimes there's actually three waves instead of one. So like in this right here, there's one wave, right? There's just an upward triangle. And this is actually what we would call an R wave. So of the QRS, here we only have an R wave. And again, we'll scroll back up and take a look at the 12 lead. Other than AVR, which we said is negative and that's normal, right? Everything else here is only showing an R wave. And that's fine. That's good. This person has a totally normal, healthy heart. But the QRS complex actually gets its name because of the three waves in it. So it's possible for it to look like this. P wave, then it goes negative, comes back up, it goes negative again, and then a T wave. And so there's actually three waves here. And I'm going to draw, so like we were talking about, this is the baseline, right? No electrical activity. And the baseline actually goes all the way through our whole complex. Okay? Now it should be a little more obvious. Now do you see the first negative, the first negative triangle right here? That is the Q wave. Then we have this positive triangle. That is the R wave. And then we have this second negative triangle, and that is the S wave. So in this morphology right here, we actually have a QRS, an actual QRS complex. Now, this one over here, this is just an R wave, right? There's no negative deflection, and there's no negative deflection over here. It's just positive, so we would just say that's an R wave. Now, the obvious question is, right, is this healthy or unhealthy, or, does it matter? And the truth is, no, not really. you know, very specific circumstances, seeing Q waves right here could be a problem. But in general, no. In fact, you can have this as well. You could have, oh, let's go back to black here. You could have your P wave, Q, R, and then a T. And in this one, we have a Q wave and an R wave, but there's no S wave. It's also possible for it to look like this. You could have P, and then we could go R, S, T. So we have an R wave and an S wave, but you notice there's no Q wave here, right? So it's possible for all of these to exist, and on a 12 lead, when you look, it's actually possible for the different leads to show different QRS morphology. Some will have a Q, R, and an S wave. Some will just have Q and R, some will just have R and S, and others could just have an R. And it's actually totally fine. If you remember the conversation from last week, they're different camera angles, right? And so they're looking at different things. The electricity is moving toward those cameras in a slightly different angle. And so the QRSs are going to look slightly different because they're seeing it from a different perspective. If we, again, to use the analogy, right, if we were to all circle around a car and then draw what we saw, we'd all be drawing the same car, but depending on the angle, it would actually look a little different. And so the same deal with the QRS. When we're looking at the heart from a slightly different angle, it's going to print on the paper a little differently. But it's okay. You can have all three of the waves. You can have one of them. In general, it's really not a big deal. Not at all. So that's why we call it the QRS complex, because of this guy right here, because it's possible to have all three waves. Doesn't have to be that way. This really up here is like the most common. This is, most likely that's what your heart looks like if we were to take a 12 lead right now. But if it showed any of the others, again, mostly no big deal. You might be asking, well, why? When does it matter? Don't worry about it. Go to medical school and we'll talk all about it. But for now, don't get alarmed that you're like, oh my God, the QRS looks different. It's fine. It can be different. Okay, so that's why we call it QRS. So the second thing we're going to talk about is bundle branch block. Okay, and I showed that to you maybe just a little too early. So here's our heart, and we know that the SA node is going to say fire. It reaches the AV. The AV is going to hold it, and then it's going to send it down the ventricular conduction system. So it's going to go down the left side, and it's going to go down the right side. Now, that's all well and good, right? Because as the electricity reaches the ends, then the ventricles are going to beat, and we're going to get a nice solid heartbeat. There's going to be an issue though. Let's say the right bundle branch doesn't work anymore. Okay. Well, what happens, right? Like, does the right ventricle stop beating? Do we stop returning blood to the lungs? Are we going to die immediately? And the answer is no, we're not. But the beating of our heart it's going to still be in sync. You're not going to feel like two beats. You're not going to feel like left ventricle, right ventricle. But they're not going to really be beating on time. One of them is going to be delayed a little bit because there's no more electricity coming out of the right bundle branch, right? The right bundle branch is not telling the right ventricle to beat. And so what ends up happening is the electrical signals from the left bundle branch, from these guys over here, actually have to go through the heart tissue. So they have to go through the muscle itself over here and tell the right ventricle to beat. And the problem with that is it takes time. So it's much faster for electricity to travel down the wires than it is to go through the myocardium, to go through the heart muscle itself, even though it's possible. And so what that does on our 12 lead, if we remember when we were talking about the 12 lead, when we go from left to right, we're talking about time. Okay, so if we zoom in really close here to one of these QRS complexes, and we count the time from here to here, okay, we notice that that's about 2 boxes, or we're going to say 0.08 in time. It took 0.08 seconds for the ventricle, for the electricity to go through the ventricle, okay, and that's normal. It can be as long as 3 of the small boxes, or 0.12. Okay, so if the QRS in terms of width here is 3 small boxes wide, no problem. And as far as how narrow it can be as narrow as we want. We don't care. But as it gets longer and longer and longer, right, that means things are taking more time. And if it's beyond 3 of the small boxes, then we have an issue. So for example, if our QRS complex, instead of looking like this guy right here, if it looked like this, okay, well that's 5, 6, 7 boxes wide. And so now we know that things are taking longer to happen, which means that the electricity isn't following down the pathway that it has been on all the rest of them, right? Where all the rest of them, it's happening really quickly because it's following down the conduction system. Now it's not happening. And so what does it look like? Well, it looks exactly like this. Your QRS is wide because things are taking longer. And so what we have down here is we have a broken right bundle branch, and it's not taking electricity anymore, and so the electricity has to come from the left bundle branches and across to tell the right ventricle to beat. And so what does that do to our 12 lead? Well, it makes all of our QRSs wide. So let's look at lead 2 here. Lead 2, okay? There is your P wave. This whole guy right here is your QRS complex, and there's your T wave. But we notice, count how many boxes, right? Count how many boxes from here, and we'll call it to here, right? Or we can even shorten it. We can even say to here. How many small boxes is that, right? Well, it's more than 3. So we know things are taking longer in the ventricle. It's taking the ventricle longer to beat. And we know that this is a right bundle branch block based on other things, but we can get into that later. But what we want to realize is that the QRS is wide. It's not narrow, right? And the one I just drew is about 2 boxes wide. As a real bonus here, because we were talking about why we call it the QRS complex, let's take a look at the one that we have circled here. Ask yourselves, what waves do I see? Is there a Q wave, an R wave, and an S wave? Is there just a Q wave? Is there just an S wave? So take a second, look at it. What do you think? What waves can we see there? So, if you need more time, just pause the video because spoilers. There's a really, really, really obvious R wave, right? This part right here. Really obvious R wave. And a really obvious S wave. What's not as obvious is the really, really tiny Q wave that we have there. See how there's a baseline and then it just goes negative just a little bit and then it goes positive? So in this case, we actually have a Q, R, and an S wave. The Q wave is just super, super small. So if you said all I see is R and S wave, no big deal. I mean, it'd be easy to miss, right? And this just comes with time. And this is also called 12 lead interpretation, so two of us can look at it and come up with different things, right? It's not really a science, it's an interpretation. So if you don't think there's a Q wave there, fair enough, we can have that debate. Cool. So that's a bundle branch block. The right bundle branches are not working. The right bundle branch is not working anymore, and so the left side of the bundle branches has to tell the right side to beat, and that takes longer. That's why our QRS is longer. It's taking more time, right? Cool. So hopefully this was a little more interesting than last week's stuff. But if you have any questions, post below. And yep, we're always here for you. Thanks, guys.